Alright.
The service host process for Windows services, or svgost.exe, is responsible for hosting and managing Windows services.
What's that? Thought Thunder went in it. See hoes.
To view this information from within Process Hacker, right-click the svgost.exe process. In this case, it will be PID 748.
What is decom launch? There's so much shit that Windows does in the background. It says don't leave. I click the servers. What? Okay, services. Decom launch. Dynamic link library. What is a dynamic link library?
From the above screenshot, the binary path is listed. Also,
I get rid of the cat cam. Oh, I got shit again. I got the shit again. There we go.
This week with Billie Eilish.
Ooh, I hope there's some spooky sketches for Halloween.
Boom!
No! Don't ever do that to me again!
I'm so sorry. This week. With Billie Eilish.
Ooh, I hope there's some spooky sketches for Halloween.
Boom!
That was a good fucking bill.
From the above screenshot, the binary path is listed. Also, notice how it is structured. There is a key identifier in the binary path, and that identifier is K. This is how a legitimate sfgoss.exe process is called. The K parameter is for grouping similar services to share the same process. This concept was based on the OS design and implemented to reduce resource consumption. Starting from Windows 10 version 1703, services grouped into host processes changed. On machines running more than 3.5 GB of memory, each service will run its own process. You can read more about this process here. Back to the key identifier, K, from the binary path. In the above screen, the K value is dcom launch. Other services are running with the same binary path in the virtual machine attached to this room. Each will have a different value for service DLL. Let's take LSM as an example and inspect the value for service DLL. Since scost.exe will always have multiple running processes on any Windows system, this process has been a target for malicious use. Adversaries create malware to masquerade as this process and try to hide amongst the legitimate scost.exe processes. They can name the malware scost.exe or misspell it slightly, such as sgveus.exe. By doing so, the intention is to go under the radar. Another tactic is to install/call a malicious service, DLL. Extra reading, Hexasorn blog. What is normal?
That's me hoes.
What is unusual? A parent process other than services.exe image file path other than c:\windows\system32 subtle misspellings to hide rogue processes in plain sight. The absence of the k parameter.
Fucking tired of being hungry.
Per Wikipedia, Local Security Authority Subsystem Service, LSAS, is a process in Microsoft Windows operating systems that is responsible for enforcing the security policy on the system. It verifies users logging onto a Windows computer or server, handles password changes, and creates access tokens. It also writes to the Windows security log. It creates security tokens for SAM, Security Account Manager, AD, Active Directory, and NetLogon. It uses authentication packages specified in LSAS.exe is another process adversaries target. Common tools such as Mimikatz are used to dump credentials, or adversaries mimic this process to hide in plain sight. Again, they do this by either naming their malware by this process name or simply misspelling the malware slightly.
Game cats are popular. Mimikatz is directly first extracting credentials deployed as a compiled binary, downloaded and loaded directly. So that's on God, what's that called? So that's an exploit you can use with Okay, it's one of my badges. Metasploit. to Mimikatz is an exploit that's used in Metasploit. When it's panning up.
What is unusual? A parent process other than wineinit.exe image file path other than c:\windows\system32 subtle misspellings to hide rogue processes in plain sight multiple running instances not running as system. The Windows logon, winlogon.exe, is responsible for handling the Secure Attention Sequence, SAS. It is the Alt plus Control plus Delete key combination users press to enter their username and password. This process is also responsible for loading the user profile. It loads the user's entiser.dat into HKCU, and userinit.exe loads the user's shell. Read more about this process here.
That's too much to give a fuck about.
It is also responsible for locking the screen and running the user's screensaver, among other functions. You can read more about this process here. Remember from earlier sections, smss.exe launches this process along with a copy of csrss.exe within session 1.
So that's normal when logged on. It'd be on 9. Open System 32.
What is unusual? An actual parent process. smss.exe calls this process and self-terminates, image file path other than c:\windows\system32 subtle misspellings to hide rogue processes in plain sight not running as system shell value in the registry other than explorer.exe. The last process we'll look at is Windows Explorer, explorer.exe. This process gives the user access to their folders and files. It also provides functionality for other features, such as the Start menu and taskbar. As mentioned previously, the winlogon process runs userinit.exe, which launches the value in hklm\software\mic.
I thought Explorer. So Explorer. I like the network part of it. Why am I fucking hungry, dude? I'm just ate. I hate when I'm trying to study and I'm just all I'm thinking about is just eating.
What is unusual? An actual parent process. Userinit.exe calls this process and exits, image file path other than c:\Windows running as an unknown user subtle misspellings to hide rogue processes in plain sight outbound TCP/IP connections.
Just show you what users is on there. I'm hungry. I'm done.
Understanding how the Windows operating system functions as a defender is vital. The Windows processes discussed in this room are core processes, and understanding how they usually operate can aid a defender in identifying unusual activity on the endpoint. With the introduction of Windows 10, new processes have been added to the list of core processes to know and understand normal behavior. Earlier it was mentioned that if Credential Guard is enabled on the endpoint, an additional process will be running, which will be a child process to wineinit.exe, and that process is lsaso.exe. This process works with lsas.exe to enhance password protection on the endpoint. Other processes with Windows 10 are runtimebroker.exe and taskhost.exe, formerly taskhost.exe and taskhostx.exe. Please research these processes and any other processes.
Let's change that real quick.